Hello there. This is a pre-calculus video. It is chapter 5, section 3, trigonometric graphs. And this should be something that is very familiar to you at this point. This is our unit circle. It's the first quadrant, and what I have up here is just an image of all of the values of sine and cosine that we have thus far computed. We've also gone as far as to transpose this information to the other 4 quadrants, but for now I think that this amount of information is enough for what we want to do today. We understand that the x-coordinate is the cosine function, the terminal point. We imagine that this blue portion of the unit circle is what we call the t-axis. It's bendy and it's wrapped around the circle. So basically, when I have a terminal point, so if I go on my blue t line, my t number line, and I am at pi over 6, this is the terminal point. So then the cosine function of pi over 6 is the x-coordinate √3/2, and the y-coordinate of the terminal point that stops at pi over 6 is the sine function, and its value would be 1/2. So basically, we could say things like, at this point, that the sine, of pi over 6 would equal 1/2, and that the cosine of pi over 6 would be equivalent to the x-coordinate of that terminal point, or √3/2. All stuff that we've already done before. Well, what we want to do today is we actually want to take that t number line and actually stretch it out and make it somewhat linear, if we will. So if we were to take this t number line, and instead of having it as a circle, if we could take the t-axis and make it horizontal, and then we could have the y-axis represent the output of the functions, then we could actually graph our sine and cosine graphs. And so I mentioned this in a previous class, so I want to remind you that imagine this happening kind of like a slinky. We know that trigonometric functions are very periodic, so once you've gone around the circle in one full cycle or revolution, then you repeat the same exact values over and over again. You could go backwards and they would still be repeating. So these functions are said to be periodic for that reason. And so if you can imagine that a slinky is basically a bunch of circles that are built on top of each other that just repeat and repeat. And if you could take that slinky sideways and stretch it out, that's kind of what we're getting at, is that you'd end up having these waves that kind of look like sound waves. And so that's one of the things that we use to model sine waves is trig functions. So that's kind of what these graphs are going to look like, but I want to get you to kind of see how that's going to happen. And the good news is that when you graph these functions, they are very systematic. So there's a way to graph them all the time. This is another image that will help you see what I'm talking about. So we are taking the values that were in the first quadrant. There, I don't know if you can tell the different colors here, but this is like a reddish, blue, purple, and like an orange color. So this reddish part is what you're seeing over here. So if you can imagine this sine curve being also 4 pieces, it's kind of like, well, that's not going to work. So it's going to be kind of like there's, one piece, here's a second piece, third and fourth. So you have these like 1, 2, 3, 4 quadrants. And so we're going to transpose that information. I know that right now that might seem like a bit much for you, but I want to talk about some of these things. And so for now, we're going to go to, sorry, I don't know why when I graphed that little guy, it didn't quite work out the way I wanted it to, but we're just going to go here. And so first I want to start with the cosine graph. So we'll go y equals sine t. So, and we're also going to do cosine t. So I want you to remember that very first image that we had, and we're going to graph the function, there's my t-axis, and here is my y-axis. And there are some things I need you guys to be aware of when you look at these graphs here. And it's these values right here. So we know, I'm not going to use all of these values, but I'm going to use some of them. I'm going to use 4 of them basically. We know that all of the t values are going to be, sorry, not the t, all of the x and y values are going to be between -1 and +1. For example, as you look at this point, it's never going to go beyond 1 because the radius of the circle is 1. So if you're not going to get a point that's out here, for example, it's not going to be out here because this is where the radius would stop at x equal to 1. So your x values are confined between -1 and +1, which would basically be your cosine values are between -1 and +1. And then if you look at the y values, which is your sine function, it's also constrained between -1 and +1 because of the unit circle being that the radius is always 1. So we know that our values for our sine and cosine curves are always going to, they're set to oscillate. That's the word we're going to be using. They're set to oscillate between the values of 1 and -1 for both functions. So here's 1 and here is -1. And so what we're going to do is, we know also that the function is periodic, so it repeats itself. And I will say this right now, this video will probably be longer than 30 minutes. So be prepared to watch it in 2 segments because it will only let me graph, or sorry, it will only record for 30 minutes and then I have to start another one. But I need you guys to have all the information and I want to take my time so that you really understand what's happening here. Another thing that I want to make sure that you know is that in the book it may ask you to graph one period, but I want you to know that I want you to ignore what the book is saying, and anytime, quiz, test, or otherwise, you're graphing a function, you are always graphing 2 periods, not 1. But for the purpose of this, this parent graph, I'm going to show you the parent graph, and then from there we're going to start shifting it left, right, up, down, all that kind of stuff like we do with all the other functions that we've learned. But for now, this is the parent graph, and I'm going to show you just 1 period of it. So what I'm going to do is on my t number line, I'm going to put 2 pi over here, because I'm going to do it in radian. If you wanted to do it in degree mode, you would just put 360, but we're going to be doing it in radian. And so there's 2 pi, and I'm going to take what is my unit circle and divide this section of my number line into 4 equal parts that represent the 4 quadrants that I have on my unit circle. That means that the first quadrant goes from 0 to pi over 2. And then if I go all the way to the second quadrant, it's pi. And then when I get to the third quadrant, it's 3 pi over 2. And then finally to 2 pi. So again, talking about this. So I'm starting, the first quadrant is going to go, my t-axis is going to go from 0 degrees or 0 radian all the way to pi over 2 radian, and then to pi, and then to 3 pi over 2, and then finally to 2 pi. So that's what I'm doing there. And so then we want to basically make somewhat of a t-table. We want to know what is the value when x is 0, when it's pi over 2, when it's pi, 3 pi over 2, and then 2 pi. Okay? So again, this is our t-axis. This is basically the blue part that wraps around the circle. And then y, in this case, is the sine function, sine of t. So the sine function corresponds to all of the y coordinates in this image. So when you have a 0 radian, the y coordinate is 0. When you have pi over 2 radian, the y coordinate is 1, and so on and so forth. So we start filling it in. We know that at pi over 2, at 0, the y coordinate is also 0. And we know that at pi over 2, which is the 90-degree angle, the 90-degree mark, that it's 1. And then we know that when we get back to pi on the other side, it's 0 again. And then when you get to 3 pi over 2, which again, if you're thinking about the circle, this is 3 pi over 2, you're at -1. And then when you get back to 2 pi, you're at 0 again. Alrighty, so these are the values that we get for the sine function. So when we plot those on this graph, you get 0, 0. Then you have pi over 2, 1. And then you have pi 0, 3 pi over 2, -1. And then back to 0. So you end up with this curve that looks like that. That's one period, one cycle, if you will, of the sine curve. This is the parent graph. This is what it will always look like. Now we can shift this graph left, right, up, down. We can shrink it and stretch it and compress it and all that kind of stuff. And we'll talk about that as the video progresses. But this is your parent sine curve. We're also going to put up here our parent cosine curve. And it's going to be very similar, but we're going to be talking about the x-coordinates as over here. So when we have 0, instead of like the sine curve, the y-coordinate is 0. In this case, for the cosine curve, the x-coordinate is going to be 1. So that's we're going to plot the point 0, 1, and then we're going to plot the point pi over 2, 0, and then on and on. So I'll do that next. So here we want to put on our t-table, I'm going to be very clear here, that we're going to have, this is sine t, and then over here in blue, we're going to have cosine t. So we're just making a t-table again. We're going to say, okay, when the t value is 0, we get 1, and then at pi over 2, which is again the 90-degree mark, we're going to get 0 for x, and then at pi, when we make our way to pi, we're going to be at -1 for the x-coordinate, and when we get to 3 pi over 2, which is here, we're going to be back to 0 for the x-coordinate, and then when you go back up to 2 pi, you're going to be back at +1. So you have a t-table that kind of looks like this, and when we plot that over here for 0, not going to put 0, 0, we're going to put 0, 1, if my pen will work with me. There it goes. And then we're going to go pi over 2, 0, pi -1, and then 3 pi over 2, 0, and then 2 pi 1. So now we have this graph that looks very similar to the sine curve. If anything, it's actually, and this is something that we'll talk about as the course progresses, not in this necessary section, but it is true that the cosine curve, if we shifted it over pi over 2 units, it would be right on top of the sine curve. So they are a phase shift of each other, so they look very similar. But this is basically what the graph looks like. So I'm also going to add some stuff to this parent graph so you can kind of have an easy way of remembering. For the sine curve, which we're going to do that one first in orange, it is said there's basically 5 points that are really important for all of your sine curves and cosine curves as whole. There's 5 points. There's the beginning. So this is my first point, second, third, fourth, fifth. There are 4 equal quadrants, but you end up with 5 points. And so the progression of the sine curve is that you start at 0. Then you are at what we call the max, because this is the maximum value that the sine curve will reach. And then you're back at 0. And then you are at the minimum, because this is the smallest value that the sine curve will reach. And then you're back to 0. So it is very helpful sometimes for you to just remember that, to have it written down somewhere, that for the sine curve, the progression is 0. I'll write it again here. 0, max, 0, min, and then 0. This is the progression of every sine curve. A sine curve will always start at 0 and then go to its max, go back to 0, go to its min, and then go back to 0. By contrast, the cosine curve starts at its max. It's starting at +1, its maximum. Then it will go to 0, then it will go to its minimum, then it will go back to 0, and then it'll end at its maximum. So the cosine curve starts and ends at its maximum. So we can do that progression here too. We can go max, 0, min, 0, max. And that'll help you when you're graphing all the other ones. So at this point, I want to give you a way of knowing how to graph this, and I hope that as we do more and more examples, it will become more and more familiar and pattern-like for you. Okay, so obviously with every function that we've learned, even when we learned parabolas back in the day, cubic functions, square root functions, log functions, exponential functions, we know that once you find a parent graph, you can also then shift it left, right, up, and down. And we've learned about whether or not these letters, so we have this formulas A cosine B times X minus C. Now, I'm pretty confident that the book does not use the exact same letters. I know that the A is the same, the B is the same, but I don't think they might use a K here instead. I don't remember what the letter that they use is, but this is what I'm doing. So like I said, you don't want to trust the book too much because it may complicate things. So this is sine, same thing, and each of these letters represents something. So A represents what we call the amplitude. The amplitude of your function is the values between which the function oscillates. So in other words, if we go back to this, both of these functions oscillate between the values of 1 and -1. So the amplitude of the parent graph is 1. So there's an actual formula for amplitude. It's the absolute value of A. So even though the numbers go between positive and negative, we say that the amplitude is 1 because there is a difference of 1 between the highest and the lowest value of the function. So it's not so much that it's positive, -1, it's how much distance is between the middle and the highest and the lowest value. So it would be 1. So that's amplitude. That's what amplitude stands for. So I want to say for over here that the amplitude of both of these functions is going to be, just going to write it in here, amplitude is going to be absolute value of A, and in this case equal to 1. And the period, which is we use the letter P for period, the period of these functions is 2 pi, and what that means is that it takes 2 pi radian to make a complete cycle. Once you go beyond 2 pi, like if you went all the way to 4 pi, for example, then you would see the function repeat itself 2 times, so that's 2 periods. It would go 1 time through, and then another time through you'd be at 4 pi, another time through you'd be at 6 pi, so it keeps repeating itself, but it repeats itself every 2 pi. Okay? That's for both sine and cosine. So over here, we want to talk about the period. So the period, there's a formula for it. Because the parent graph period is 2 pi, the period is going to be determined in these scenarios by 2 pi divided by b. So that's what that b value is doing there. That's going to help us figure out the period. Alrighty? And then the other letter here is the c. So the x minus c is what we call a phase shift. Basically, it's kind of the equivalent of a horizontal shift, so I'll put that here in parentheses. The horizontal shift is basically what the c value is. So when you have your x minus c equal to 0, all right, that means that you're going to take, and technically you could even include the b there. This is bx minus c equals 0, but because if you divide both sides by b, it's the same thing. So x minus c equals 0 is fine. So that's how you're going to get your phase shift. which I'll just tell you right now is what I'm going to be calling the left endpoint. I'm going to not abbreviate that for this first time and just call it left endpoint. That's the word that I use. Left endpoint. It's basically going to be where we start. Okay, so I told you guys in class the other day that when you graph sine and cosine curves, you can technically start anywhere, but in order to keep this consistent, we're all going to do it the same way so that when we grade and when we're checking for accuracy, I don't have to be doing it 5 different ways. So we're going to start with what we call our left endpoint, and the way that we're going to find our left endpoint is by taking the x minus c and making it equal 0. So that's our phase shift, and then of course, I think that you guys can get D what we would call your vertical shift. So just like before, if you have a +5, it means that the graph's going to shift 5 units up. If you have a c value here, it's going to shift it c units left or right, depending on the sign of the c value here. B is going to affect our period, and A is going to affect our amplitude. Now, we're not going to start using all of those letters right off the bat. We're going to start off with some easy examples, and then we'll gradually graduate to where we'll start using all of this stuff, and it'll make more sense. Okay, so for that, we want to go back to over here, and we want to get my example page going on, which is right here. This is our first A and B examples, and so I want to graph part A. I will say this, when I thought about whether or not to give you a grid, I don't usually use the normal grids for these graphs because of the nature of the graph, that it's going to keep going horizontally more so than vertically. We don't use a typical, standard coordinate plane. So I'm going to be, and you'll see this a lot, I'm just going to always draw my horizontal axis. Let me get in here so I can write. My horizontal axis, and I make it, generally longer than, you typically would see. And remember what I said earlier about always wanting 2 periods. So we're going to call that X. And remember that even though it says X, it's basically like the T number line. And then I'm going to do this guy. And I probably should have made this a little bit further down, but I'm not going to erase it at this point in the interest of time. But we have here 2 plus cosine X. So in this case, we don't really have crazy A values because remember that the A value would be right in front of the cosine. So in this case, the A value is 1. And remember that the amplitude is the absolute value of A. So in this case, our amplitude is the absolute value of 1, which is just 1. That tells us that the graph is going to bounce around, oscillate between 1 and -1. It also doesn't have a number in front of the X, so there's no B value, there's no C value, there's only a D value. So that D value is telling me that this graph is going to shift 2 units up, which is why I was just saying that I probably should have put this a little lower so that I could have space to go up. But that's okay, we can still do it. So I'm going to go with 1, 2, 3. And what I like to do is to draw myself another horizontal axis because I know that this graph is going to shift 2 units up. So instead of the middle of the graph being right on the x-axis, the middle of the graph is going to shift 2 units up. So what I like to do is to just go ahead then and draw in a dashed or broken line that will represent my horizontal axis so that I don't have to get all crazy over here. All right, so that pretty much takes care of the +2 part. And then the cosine curve oscillates 1 unit above that middle. And that's what I was talking about when, let's see if I can go back here real quick. So that's what I meant between, so this is like the middle of the graph. This is like 0, and you're always going 1 above or 1 below. This is the middle. So when I drew that horizontal axis, it now acts as my middle, and from that middle, I have to go up 1 and down 1. So in this case, I'm going to be going up 1 from the middle, which would be 3, and down 1 from the middle, which would be 1. Okay? So 2 is my middle now, and I'm not exactly sure why it doesn't want to write 2 there, but it does not like the number 2. I'm going to try it one more time, and if it doesn't work, I'm so sorry. Okay, don't know. Anywho, doesn't like the number 2. Or actually, you know what I think it happened? I think that it's because I have it still on this dashed line business. That's what it was. So let me go back to not dashed. And then it'll work this time. So sorry about that. It was doing it with a broken line, so you weren't able to see the whole number. Anyway, so there's that. And so we're going to go between there and there. So remember the cosine curve. So now what we need to do is put our values on the x-axis. That's the most important part of this graphing thing. So remember that you want 4 equal parts, but I told you earlier that you always want to graph 2 periods. So technically I need 8 equal parts. So all I'm going to do is, I know I'm going to start at 0 because the cosine curve always starts at 0 unless there's a phase shift. And in this case, there's no C value, so there's no phase shift. So I'm starting at 0, and I'm going to end over here somewhere. And the period of a cosine graph, unless there's a b value, which again, there's no b value here, the b value is 1. So the period of this function is 2 pi. So if I want to have 2 periods, I need 2 times 2 pi, which would be 4 pi. So over here, I'm going to put 4 pi. And then I'm just going to kind of ballpark it. I'm going to try to find more or less the middle is right about here, and that would then be 2 pi. All right? And then I take my period, and I got to make it into 4 equal quadrants. So I'm going to cut in the middle there, the middle of that, and the middle of that, and I get my 4 equal quadrants. And so now I'm going to go from 0 to pi over 2, to pi, to 3 pi over 2, and then 2 pi. And then do the same thing over here. Get my equivalents there. And now remember, this is, another way of looking at it is this is 1 half, 2 halves, 3 halves, 4 halves. This is 5 halves, 6 halves, but 6 halves is just 3 pi, 7 halves, and then 8 halves, or 4 pi. So now I have enough space to get 2 full cycles here. All right? So then that's where we want to start using what I was talking about earlier, which is this stuff. Okay? And to know that it's max 0, min 0, max. So when I go to my graph here, this is the cosine curve. So I know that cosine starts at its max. So here's 0, and it starts at its max. So I'm going to put a dot right there. At the next value, it's going to be at 0, which is why I put that horizontal line there, so that it can help me kind of put my dots where they're supposed to be. And then at pi, it's going to be at its minimum. And then we're going to go back to 0, and then back to its max. So we said this before, cosine starts and ends at its max. So that's where you're going to get your curve going, and then you just do it again. So then for here, you're going to go back to 0, so we go max 0, and then min, and then 0, and then back to max. All right, and then you want to connect it with a smooth, rounded curve. I don't want to see W's, and I see those a lot, so I will be marking you off for that. I don't want your graphs to look like absolute values, hence why I said W's. In other words, your graph should have this nice little curvaceousness going, none of this like W action happening. All right, so just make sure that you're not doing that, but that would basically be the graph of 2 plus cosine x. It would oscillate between 3 and 1, but that's still 1 unit above, 1 unit below my new middle, which is 2 because of the D value that was 2 here. Even though the amplitude is still 1, the values that it bounces between are 3 and 1. So I have 2 periods. Here is my 1 cosine curve, and then my second one, and then it would just keep repeating, but like I said, you only want 2 periods. So there's that. I'm going to erase this now. And then I'm going to do another one, which is part B, which is negative cosine x. And you're probably thinking, oh no, negative cosine x. So I got to grab my ruler where I put that little sucker. Here he is. So I'm going to, this one doesn't have any vertical shift. There's no +2 or anything. So I don't have to like, go up or, I'm just gonna do a standard, number line or coordinate plane here.